connectives and truth tables?
Oh, it's pretty simple. Let me explain to you, okay? Basically, they have 5 logical connectives, which is negation, conjunction, disjunction, implication, and biconditional.
Logic is an important topic in discrete mathematics because it helps us to determine whether a statement is true or false. In computer science, logic plays a major role in programming, decision-making system, and digital circuit. In this presentation, we will discuss the fundamental concept of logic, including proposition, logical connective, truth tables, to understand how logical statements are formed and analyzed. What is proposition? A proposition is a statement that can be clearly determined as either true or false. In other words, a proposition must have a definite truth value.
What is logical connectives? Logical connectives are symbols or words used to connect two or more propositions to form a new statement, which is called compound statement. For logical connective, we have 5 symbols. First is negation. Negation means it's not. Next, we have conjunction. This is the symbol. For conjunction, the meaning is and. And this is disjunction. For disjunction, the meaning is for or. And the second last one is implication. Implication is if, then. And for the last one is biconditional. And this is for if and only if.
First symbol for logical connective is negation. For example, P, I submit my assignment on time. Negate P, I do not submit my assignment on time. Now, let's do the truth table. Negation truth table. If the P is true, then the negate P is false. While if the P is false, then the negate P is true. This is the final answer for the truth table. The second symbol is conjunction. For example, P, I study, Q, I do tutorial. P conjunction Q will be I study and do tutorial. Now, let's do the truth table. This is conjunction truth table. If P is true and Q is true, then P conjunction Q is true. If P is true and Q is false, then P conjunction Q is false. False. And Q is true, then P conjunction Q is false. Lastly, if P is false and Q is false, then P conjunction Q is false. This is the final answer for the truth table.
For the third symbol is disjunction. Disjunction is or. For example, P, drink coffee. Q, drink matcha. P or Q, which is drink coffee or matcha. Let's do the truth table. This is disjunction truth table. If P true, Q true, P or Q will be true. And if P true, Q false, and P or Q will be true. If P false, Q true, and the disjunction will be true. For the last one, if P false, Q false, P or Q will be false. This is the final answer for the truth table.
As for the next symbol is implication. Example, P, I study, Q, I pass exam. P implies Q. If I study, then I pass exam. Let's do the truth tables. This is the truth table for implication. If P true, Q true, then P implies Q will be true. If P true, Q false, P implies Q will be false. If P false, Q true, then P implies Q will be true. If P false, Q false, P implies Q will be true. This is the final answer for the truth tables.
Now I will explain about biconditional, which is if and only if. So for the example, we have P equals to login successfully and Q is for the password is correct. So we have P biconditional Q, which is I log in successfully if and only if the password is correct. Now let's do the truth table. So this is the truth table for biconditional. So first we have P true and Q true. So P biconditional Q we get true. So then we have P true and Q false. So P biconditional Q we get false. For P false and Q true, P biconditional Q we get false. So if we get P false and Q false, the P biconditional Q is true. And this is the answer. Let me explain about exercise 1. So here we have P or Q biconditional R. So for make the truth table, P must start first. So in the table of P, we need to fill in for the first 4 row is true and the last 4 row is false. Next, for the table Q, we need to put 2 true and 2 false. And lastly, we have R, we need to put true, false, true, false, true, false. Now we're gonna do table Q biconditional R. So for table Q and table R, in the first row we have true and true. So we're gonna get true. And second row is true and false. So we're gonna get false. Next, false and true. So we get false. And false, false, we're gonna get true. And true, true, we're gonna get true. Also, true and false, false, false and true is false. And lastly, false and false is true. For the last table, we're going to do P or Q biconditional R. So we need to see the table of P or Q biconditional R. So now, in the table P, we have true and Q biconditional R is true. So P or PQ biconditional R, the answer is true. Next, we have P true or Q biconditional R is false. So the answer is true. Next, we have P true and Q biconditional R is false. The answer is true. Next, the P true, Q biconditional R is true. We got the answer is true. Next, we have P false and Q biconditional R is true. The answer is true. Next, if P is false and Q biconditional R is false, the answer is false. If P false and P biconditional R is false, also false. And lastly, we have P false and Q biconditional R is true. The answer is true. So that's the answer for exercise 1.
Now, we are going to do exercise 2. The question is, negate P and Q. So, the first thing we have to do is fill out the truth value for P and Q. Now, we are going to fill out the first column, which is P and Q. For an statement, the statement is true if both statement is true. So, if P is true and Q is true, then P and Q is true. If P is true and Q is false, then P and Q is false. P is false and Q is true, then P and Q is false. If P is false and Q is false, then P and Q is false. Now, we are going to look at negate P and Q. For negation, we are going to take the opposite value of the current value. So, for P and Q, if the value is true, then negate P and Q will be false. So, for the first row, the negate P and Q will be false, while the other remaining 3 will be true.
For conclusion, we know that proposition is a statement that have a true value which is true or false. We also learn 5 basic logical connective, which is negation, conjunction, disjunction, implication, and bioconditional. Besides that, truth table help us to determine truth value. Overall, this concept is very important in discrete math. Also, we apply it into computer science, especially in programming and logical problems.